Using Venn diagrams in mathematics. What is a Venn diagram? A Venn diagram is a representation of categories using overlapping circles or enclosed shapes. Each circle represents a different category, with the overlapping chunk representing the shared characteristics between the categories. In the example below, the blue group represents one category, the yellow group represents another category, and the green is the shared characteristics between both groups. Venn diagrams are very useful in mathematics classrooms because in math, two things are either equal or not equal. There is nothing in between. Using Venn diagrams, students can compare and contrast two sets, functions, groups, or categories for equalities and inequalities. One example of a use for Venn diagrams in a classroom is to have students use a Venn diagram to compare the qualities of two graphs. To demonstrate this kind of use, we are going to compare the graph of y equals sine of x to the graph of y equals cos of x. Here, we have the graph of y equals sine of x on top in red, and the graph y equals cos of x in blue on the bottom. When we bring these graphs onto the same grid, we can see that they do not share many points, only 2 per period. However, using a Venn diagram, we will compare whether these two graphs share other qualities. The first quality we will compare is whether each of these graphs have any asymptotes. Sine of x has two horizontal asymptotes at y equals 1 and y equals negative 1. Similarly, cos of x has two horizontal asymptotes at y equals 1 and y equals negative 1. Therefore, we can put the asymptotes quality in the shared characteristics. Now moving on to amplitude, the graph of sine of x has an amplitude of 1, and the graph of cos of x also has an amplitude of 1, meaning we can move amplitude into the shared characteristics. Moving along, both graphs have the same domain of x element of real, so we can again move that to the shared characteristics. Both graphs have a range of negative 1 to positive 1, showing yet again that these graphs have something in common. Keeping with the trend, both of these graphs have a period of 2 pi, moving that to the shared characteristics as well. Lastly, when looking at the zeros of both graphs, we finally find a difference. Now, looking at our Venn diagram, we can see that although these graphs only share a few points, they are in fact very similar. By using a Venn diagram to compare the graphs, a student will have a better grasp as to how the graphs are the same than they would had they just looked at the pictures of the graphs. Venn diagrams offer a unique way to display similarities and differences between two things. Because of this, they are a very useful tool in a mathematics classroom.